Hi there, so welcome to another video. Today I'm going to discuss on solar DC light setup and the need for it from the Indian perspective. Basically, why suddenly solar DC light? Well, um, let's say you were inspired by solar articles that you've read on the news and you wanted to think, hey, how can I contribute positively to the environment? Well, you install the basic solar lights. That way you are contributing less to the pollution, because most of the electricity that is generated in India, 60% of them come from thermal. And also there are some practical aspects as well. Let's say you have a remote location where electricity reach is very limited. That's when solar DC light setup comes very handy, especially if you have a backup, and where electricity is not very erratic. That's where solar DC light comes into the picture. So enough of the motivation. So let's go to the agenda of this aspect. So the agenda is like, I'm just gonna go through the basic design of the solar light and the minimum viable product. We'll go over the battery design philosophy. Basically, I'm gonna consider lead acid batteries currently. I've seen vendors of lithium ion as well in India, but I'm not really sure about the quality. That's why I'm not recommending. And of course, lead acid has been in the market for a long, and it's cost less, and the charger is also less complicated. The and also the also the risk of damaging the battery is much lower in lead acid. And from what I have seen in the market in India, at least, the warranty of a top-notch lead acid battery almost matches the warranty of a third party manufacturer in India, lithium ion at least. I may be wrong, because most of the lithium ion that comes through the Indian manufacturers are through China. It's like usually trading. So correct me if I'm, if you could give me some reliable lithium ion battery sources, that's really appreciable. Maybe on the next video I'll go and create that. I'm for lithium because it's used in Tesla and all. And it's the latest technology, and doesn't occupy much space compared to lead acid. It can essentially go through much more higher charge discharge cycles, and and its lasts generally typically longer and is maintenance free. So all those advantages will cost you more. So I'm just gonna be very, very bare bones kind of a system design. So I'm going to talk about how we choose the panel size, the solar panel that I'm choosing, and even the lead acid, the battery, what's the capacity of the battery, and what's the backup that you're expecting, and in the last, I'm just going to go over the approximate costing. So that's the treat of this video. The thing is, I'm gonna see I've curated some of the I've gone through Amazon India links, and I've curated a list of items that you can procure. You can directly procure from Amazon, and hassle free. So it's very hassle free for you to set up one at your place of interest. So without further ado, let's illustrate the design. So the design is very simple. Basically, you have solar panel. Basically, a very crude solar panel. It can be a monocrystalline, or you have polycrystalline. So basically, these are the two major types. Fundamentally, this is a bit more high efficiency. Of course, higher efficiency, but higher price. Whereas this has a little bit lesser efficiency, lesser price. But nowadays, it's because of the technology, because of the mass manufacturing, the costs have almost become equal. So I would recommend for a monocrystalline panel. So once you choose the panel, I'll show the sizing of it. Once you choose the panel, you choose a stand. Basically, that is also very important. You have to have a stand, otherwise and the stand has to be oriented towards the sun based on your latitude. It has to be towards the south, basically, and approximately at an angle inclined equivalent to the latitude. So that's very important. That actually increases the overall sunlight that is received throughout the year, because sun is not interesting fact about the sun. If you observe the sun, it does not follow the same trajectory throughout the year. It changes, basically. So to account for that, on a I'm simplifying it for you. Just orient it towards the south at the latitude angle. So you have a stand, and then you have MC4 connectors, basically. So these are typical connectors. These are solar connectors which connect. These are DC wires, so you need appropriate DC wires based on the current that you are flowing through. And these DC wires, remember, they're going to be out in the sun, and they have to be UV protected. So that's where you actually end up spending a little bit of money, but it's worth it. And then typically solar panel is outside on your roof, but then comes the electronics. So I'll be typically suggesting MPPT charger. So what is an MPPT charger? Maximum power point tracking. So this is the latest technology wherein it's able to extract the maximum power that is available, especially because in the sunset and the sunrise times, and when the sun is near the horizon, that's when this MPPT charger can extract the most out of the panel. But then there are other chargers which is called as the PWM chargers, which are essentially a little bit inexpensive, almost 1/3 of the price of an MPPT charger. But the efficiency that you'll get, the amount of power that you can draw from the panel is considerably less. And of course, the design is easy for PWM, but a design is a little bit complicated with MPPT chargers. Usually you have basically a microcontroller involved that actually tracks the maximum power point at any given time. And let me not deviate too much into it. So you have MPPT charger, and then MPPT charger goes to your your lead acid battery. And it's usually 12 volts. That's what I'm choosing. And then and this basically, you have a discharge protection circuit, or like under voltage discharge protection circuit, so that it does not go below 12 volts, because if it goes below, it will end up damaging the the lead acid battery. But I'm not putting an over voltage protection, but because over voltage is usually inside the MPPT charge itself. So over voltage protection and all those protection is already there in that MPPT charger. So basically it's going to charge up the battery, and then through the discharge circuit, I'm going to suggest let's say you want 12 hours operation of your 12 hours operation of your lights, right? So let's say in the morning you don't need it. In the evening, let's say from 6 p.m. to 6 a.m. in the morning, especially, let's take a typical scenario of a farmhouse wherein you typically have, let's say we are going to design 5 lights. Okay, so I'm going to use 5 lights, 5 DC lights, 20 watt of them, 20 watt, so that you can see I'm just directly connecting this with the DC lights. And what is this? This is actually the 12 hours on, 12 hours off circuit. of circuit. So there's a relay basically that I'm gonna reveal as a part of the costing section. Yeah. So you have so after this, it is gonna supply again. You have DC wires based on your 20-watt rating. You have 5 lights, basically 20-watt lights, and this is the automatic control. You can also have manual switches, which are like, the bedside lamp switches that can also be connected in series, so that you have control basically. Let's say you don't want to discharge much. So yeah, so this is the basic design. It's very, very basic design, and I'm just going to talk about, it has to be a decent one. I'm going to take into account, you have rainy days rainy days, and you know so, and cloudy days, basically when you don't have solar. And I want to ensure that you have enough juice to have 12 hours backup for at least 2 days. That's the design target that I am targeting. So let's do this. Let's go to the battery design philosophy, battery design, and the PV sizing philosophy. Let's see this in the next video. Thanks.